The difference between games and movies is player input. Today we're going to see how to handle input in Unity 6. If you're familiar with older versions of Unity, we're going to briefly see the old input system and compare it with the new one and see the various ways that we can use the new input system. Before we start, I invite you to check out my Unity 6 and C# programming crash course for complete beginners on Udemy. This is an adventure game where we're going to have a character that's going to move around. We're going to have some traps, some collectible items like coins. In each level, you'll have to collect a number of coins to unlock the exit and move on to the next level. We're going to do some level design, and I'm going to show you how to turn a simple scene into a complete project with a loading screen, with menus, with transition between the scenes. Right now, I'm working on more chapters where we're going to add more adventure elements like puzzles and more traps and enemies. So it's really exciting, and if you guys are interested in a beginner to intermediate tutorial, I believe this is the best resource that you can use to learn Unity and expand your knowledge on how to actually make a complete game. So check it out using the link in the description. Thank you, and let's move on with the rest of the video. Okay, let's talk about input. There are usually two ways that we can handle input. We have the device-centric approach, where your code has direct access to the buttons that have been pressed. So here, if I press a button on the keyboard, I can directly know about it in my own code. With this approach, we have no abstraction between the devices and your own code. If on one side we have the device-centric approach, on the other side we have the player-centric approach. We have something in the middle between the devices and your own code. We have actions, and the devices can be bound to some actions. For example, the space key on the keyboard can be bound to the jump action. We can also bind touchscreen controls to these actions if you have a mobile game. And then in your code, you don't actually manipulate what happens on the devices, and your own code doesn't even have to know which device has triggered the action. All it cares about is that the action has been triggered. For example, if we connect to the jump action, for example, we make the player jump whenever the jump action is triggered, then it doesn't matter to our own code whether the jump action has been triggered by a button on the touch screen or by a button on the joystick or the gamepad or a racing wheel or anything. All we care about is when this action happens, what's going to happen in our game. Now in Unity, we used to have the old input system, which is called the input manager. You can still access it and use it, but in Unity 6, it is by default disabled in every new project. And the input manager used to use this device-centric approach. So you only have direct access to the buttons on the keyboard and on the gamepad, etc. And if you wanted a level of abstraction, you had to make it yourself or perhaps buy an asset from the asset store. I used to use the reward asset before the new input package was developed by Unity. But now we have the new input system, which follows the player-centric approach. What we're going to do is we're going to go back to Unity and show you briefly how the old input manager worked and how we can achieve the same result with the input system. In case you're already familiar with the input manager, you will have an easier time transitioning to the new input system. Then we're going to see how to actually use this player-centric approach in our own code. And this player-centric approach is actually the better one because it allows your code to not change as long as you're connected to some actions. You can rebind them to any device you want. And in Unity, you have a nice interface to do so. Then we can have things such as an options menu to allow the player to choose which button is connected to the actions. Okay, back to Unity. Now let's go to Edit, Project Settings. Now for the old input system, let's go to Input Manager. And here we have the axes. Here we have the horizontal axis, the vertical axis. These are bound to the WASD keys or the arrow keys. And usually if you want to make your character move, this is what you're going to use. Now, in order to use this, we're going to go to player, then scroll down to configuration. Then we're going to choose the active input handling method. In my current project, it is set to both, but if you create a new project in Unity 6 and onward, it's going to be set to input system package, the new input system, not the old one. Therefore, the old input system will not work. Right now, it is set to both, so both ways are going to be valid. Okay, let's create a script where we're going to manage input the old way. I'm going to go ahead and delete all the methods. I just want the update method. Now, in order to use the input manager, we can use the input class. To get keyboard input, we have access to get key down, get key up, and get key. Get key will be called every frame as long as the key is pressed, but get key down and get key up will only be called on the frame where the key is down or up. So let's use get key down and let's give it a key code .g, for example. When we press the G key, we're going to write something on the console. Let's write the G key has been pressed. We also have access to the mouse buttons with get mouse button down, get mouse button up, and get mouse button. It works the same way as get key. Here, as long as the mouse button is held down, the get mouse button method will return true. But for mouse button down and up, it will only return true in the frame where the button has been pushed down or has been released. So let's say get mouse button up, and let's give it the button. So the 0 is the left mouse button, and I believe the 1 is the right mouse button. Let's say LMB released when the left mouse button is up. Okay, now let's add a vector 2 here. Let's call it horizontal axis. And in the update method, I'm going to get that axis. So we're going to say horizontal axis equals input.get axis. And we have two ways of doing this. Get axis row will return the row value from the device, but get axis will return a value that has been processed a little bit. So let's say get axis, and let's type here horizontal. Yeah, we have a problem here. This should in fact be a float, not a vector 2. Let's create an object here that we're going to use to attach the script. So let's click on this plus button, create empty. Then let's call it old input test or simply input test, and I'm going to have my script here. So let's drag and drop the script here. Okay, let's run the game. Now let's open the console. Okay, I have to focus this view, so I'll have to click on the LMB and release. And when I release LMB, it says LMB released. Now let's press the G key. Okay, as soon as I press the G key, a message is printed on the console. Now for the horizontal axis, if I press either A or D, I will get a value. For example, here for D, I'm getting the value of 1. Then it goes back to 0 when I release the D button. Same for the arrow keys. When I hit the left arrow key, I get a value of -1 here on the horizontal axis. Then I'm going to release and the value is going to go back to 0. Okay, this is the old input system. While we're still in the device-centric approach, let's do the same thing, but now with the new input system. But before we do this, let's also get the mouse position. Let's add a serialized field here. Serialized field, vector 2, mouse position. And in the update method, we actually have two ways of getting the mouse position. We can get it with input.mouse position. We have it here. We also have access to mouse delta, but we also have access to it through an axis. In input manager, we have the mouse X and mouse Y axis. We can use them to get the mouse position. So let's say here, mouse position equals new vector 2, or we can say simply dot X equals input get axis mouse X. And we can do the same for mouse position dot Y. I'm just going to copy this line. Mouse position.y equals get axis mouse Y. Okay, let's save the script and run the game. Okay, I can see that the mouse position is actually the mouse delta, not the actual position of the mouse on the screen. So I still need to get the mouse position using input.mouse position. And for this axis, it's actually how much the mouse cursor has moved. So yeah, it's indeed the mouse delta, not the absolute mouse position. So we're going to see how we do this with the new system. Let's create another script. Let's actually just duplicate this script. Let's call it input system test. We're going to do basically the same thing that is happening here in input test. So I'm going to rename the class to input system test, we're still going to have the horizontal axis and the mouse position, but now we're going to use the new input system. So let's import the namespace. We're using the input system namespace. Instead of input.getKeyDown, we have access to the keyboard class. We're going to use keyboard.current.gkey.isPressed, and we're going to get basically the same result. We also have access to more properties. We have access to was pressed this frame or was released this frame. So I just contradicted myself. We should actually be using was pressed this frame, not is pressed, because in fact is pressed is the equivalent of input.getKey, not getKeyDown. So we're going to say was pressed this frame, and we're going to do this. Then for the mouse input, let's replace input.getMouseButton up with mouse.current.left mouse button or left button was released this frame, and we're going to get the same result. Then for the horizontal axis, we have access to the horizontal axis through actions, which we're going to see a little bit later. So I'm going to comment this line out. To get the mouse position, we can use mouse.current.position.readValue, and it's going to return a vector 2. Every time you want to use a keyboard, you have to actually say which keyboard you want to use, because the input system can handle multiple keyboards for games with local multiplayer, for example, and it can also handle multiple mouse devices. That's why we always use current, and usually you will only have one mouse at best. Let's save this and we're going to test it. Now let's go to input test and let's remove this script and replace it with our input system test script. Now let's run the game. If I click on the game view, I get LMB released, and then if I press G, I get the G key has been pressed, and here I can see the mouse position. So whenever I move my mouse cursor, the position is being updated. Okay, this is the device-centric way to use the input system in Unity. And if you're coming from the old input manager system, you will be in familiar territory using the system like this. And I invite you to look into the documentation or use your autocomplete feature like IntelliSense in Visual Studio to explore all the properties here. For example, in keyboard.current, you have all the keyboard inputs here as properties that you can use. Let's remove this and hit Control space. So you get G key, H key, all the keys in the keyboard, numpad, and basically all the keys. You can also have access to any key. In the old input system, it's input.anyKey or any key down. For example, if your player comes out of the loading screen and you want to show something and ask the player to press any key to move on, then you can use it here. But the true power of the input system is the player-centric approach that we're going to see right now. In the player-centric approach, we need to define these actions. In Unity, these actions are defined in an input action asset, which is a file in your project. When you create a new project, you will have one input action asset, which contains the project-wide actions. If you want to edit this, you have to go to the project settings window. Instead of going to the input manager, we go to the input system package, and here you can find the reference to our file. If we click on it, we can ping it in the project view. And here we have a bunch of actions organized in two action maps. We have player, then we have UI. So here we have the move action and the look action. And for each action, we have an action type. So the move action is of type value. Let's unfold it here. We can see the bindings of this action. So this action is bound to the WASD keys and also to the stick on the joystick and the left stick on the gamepad. We have the look action, which is bound to the pointer delta. Then we have the attack action, which is a button, the interact action, crouch, jump. Then we have the UI actions, and here you can add your own actions by clicking this plus button. Then you need to define the name of this action. For example, let's call it pet cat. If you have a cat in your game, this action will be used to pet that cat. Then let's unfold it. It says it has no binding. We have to choose the type. So the type of the action is a button. In most cases, you'll want to use either a value or a button, but you can also use a pass-through. In some cases, if you want to skip the filtering that the input system does on the button, you can use a pass-through action, but in most cases, you can simply use a button. By clicking here on no binding, I can bind this action to something. So let's choose path. Then here we can choose the devices that we want to use. Let's pick keyboard. Then let's pick by location of key using the US layout. And this is great because if your players have different keyboard layouts, you can bind your action to a key on the US layout, and Unity will automatically translate this into the keys in other layouts. So we're going to use US layout, and let's bind the action to the P key, and it needs to be of type button, not value. Okay, now that we have our input actions, we're going to close this window. Now let's access the project-wide input actions from our script. Let's go back to our script. Here I'm going to access the project-wide input actions. Let's add a start method. But before we do this, perhaps we can go to the documentation. Let's open the package manager by going to Window, Package Management, then Package Manager, and let's go to In Projects and look for the input system. Then let's open the documentation. It's always important to read the official documentation. It's fine to get your information from YouTube and from other content creators, or maybe even written tutorials, but your primary source of information should be the official documentation. And I'm not only talking about Unity, I'm talking about any asset you use inside of Unity and even in other game engines. Your primary source should be the document that is, or the documentation that is written by the people who have created the system. Here, if you go to the documentation, you can go to workflows, and right now we're using the direct workflow. We've used the keyboard and the mouse classes, but here you have an example of the gamepad class. So you have a lot of explanations on the direct workflow, and we have other workflows. We have actions. We've seen how to edit the actions in the editor. Then we have accessing your actions from code. Let's go back to our code to access our project-wide actions. Let's use input system.actions, and let's use the find action method. And here we need to specify the name of our action. Let's say pet cat, and here I made a mistake. We should not be doing it in the update method. In fact, it says so in the manual. It's enough to do it in the start method. So let's do this here, and let's save the value in an input action object. Let's call it pet action, and let's do it like this: pet action equals this. Once we have our pet action, then here we can use an if statement. If pet action was pressed this frame, then we can write something. Our action is of type button, but if it was a value, we can use value.read. Like we did for the mouse position, we use the control.read value to get the actual value. So let's close this, and we're going to test our code. It says we cannot convert this method. So indeed, this is a method, not a property. Okay, so we have to use the parentheses. Okay, all right. This was my mistake. I thought it was a property, but actually it's a method. Was pressed this frame. Let's run. And I'm going to hit P on the keyboard, and it says you're petting the cat likes it. Okay, now we also have another option here. Let's go to the settings folder where I have my action asset. We can in fact generate a C# class. It's going to be saved as input system actions.cs, and this is the class name. It will be the same name as the file, and this is great if you want to access the actions through regular C# properties. Here our only option to find the action is to use the find action method, but if you convert your file into a C# class, then you can access this action like any other property. Doing it like this is faster in terms of iteration, because if you were to generate the C# class, you'll have to regenerate it again anytime you change your actions, which can be a bit tedious, especially in prototyping or at the beginning stages of your project. Let's talk more about actions. Right now we're using the project-wide action asset, but we can also create an action in the monobehavior itself, and you have an example here in the documentation. You can declare an input action here on your script. This action will live inside of your script itself, and you can configure it in the inspector. And it says here in the manual that unlike project-wide actions in the project settings window, you must manually enable and disable actions and action maps that are embedded in monobehavior components. So in the monobehavior itself, you have to add an onEnable method then call enable on each action. And on the onDisable method, you'll have to call disable on each action. And you also have the option of having a whole action map here, not only an input action, which is an individual action. Now let's go back to the horizontal axis that we didn't define. And instead, perhaps let's use a vector2 and let's call it the move axis. And here let's declare another action, input action, move action. And let's get it here, move action. Input system.actions.find action move. And here in the update method, we're going to say move axis equals move action.read value with vector2 as a type. And we're doing this because the move action, unlike our pet action, is a value, while our pet action is a button. And by the way, we can either check the state of the action in the update method, or we can add callbacks. For example, here we can say pet action dot performed, and we can add a callback whenever this action is performed. And for the callback method, we can use a method with this signature, input action dot callback context. Then we can do whatever we want here. And in fact, we should perhaps talk about the states of the action. The action starts. So indeed, we can add the started callback. Indeed, we have the started action, then we have the performed action, then we have the cancelled action. Now for a button, as soon as it is pressed down, the started event and performed event are called. Then when you release the button, the cancelled event or action is being called. You can add some callback methods here, or you can check the state of the action in the update method. So we can say if pet action was released this frame, which is the same as adding a callback method to the cancelled action. Okay, let's remove this. Now let's look at the other workflow, which is using the PlayerInput class. This is actually the workflow that I show in my RTS camera tutorial. To use this workflow, we add a PlayerInput component to our object, and this PlayerInput component is provided by the input system. Let's go to our input test object, and I'm going to add a component. Let's type PlayerInput. This is our PlayerInput script. Now, in some versions of the input system, if you use project-wide actions here, it's going to say, watch out, you cannot use project-wide actions here, but in fact there's no issue with that. The only detail that you have to understand is that the PlayerInput component creates its own copy of the input action asset. So if you modify the input asset inside of PlayerInput, it's not this actual file that's going to be modified. This is only relevant if you're implementing some input rebinding code in your game, but for practical purposes this doesn't really matter. So here we have a lot of behaviors that we can choose from. We have send messages. What this will do is if we define these methods in any script here on our object, the PlayerInput class will call these methods. So for example, if we define an onClick method or an onMove method, then it's going to be called by PlayerInput. If you define a default map, the other map will not be active. In some versions of the input system, this is not the case. When I made that tutorial video on the RTS camera, all the action maps were enabled, so I could use any action from any action map, but in later versions it was no longer the case. A solution that I suggested in the comments of that video was to simply go to the project settings, and here in the player map, if you need an action from UI, you can just drag and drop it here on the player action map. That way your PlayerInput script will have access to all the actions that you need. Let's define one of these methods. Let's define the onMove method. Let's go back to our script. Then let's define the onMove method here. And it needs to have a special signature. It needs to take an input value. And it doesn't matter if the method is public or private. It will work either way. So in onMove, let's print the value. Let's say vector2 move input. And let's set it to value. And let's say value.get with a vector2 as a type. And now we have access to the move input. Let's debug log it. That way we print the value of move input when we get it. Let's go to the console, and if I move, you will see that the move input is being printed. If I press W, I get 0, 1. If I press S, I get 0, -1. And here I get two events in the case that the button is pressed and released. When it's released, I get a value of 0, 0. All right, let's go back to input test. This was the send messages behavior. What I I honestly prefer is the send or invoke Unity events workflow or behavior. And here we get an events foldout. Let's unfold player and let's unfold pet cat, for example. And here we can bind a method on any script to this field. Let's go back to our script and let's add another method here. And this time it's important that it is a public method. That way we can bind it to the event here. Let's add a public on pet, and it needs to take input action.callbackContext as a parameter. And now we have access to the context. So let's say if context performed, and we can say else if context is cancelled. That way you can do something when the button is being released. Let's say here petting the cat, and then here done petting the cat. I forgot the void here, public void. Now back to our input test object. Let's drag and drop our input system test. And let's look for our method here. Let's look for input system test, then on pet is going to be on the top. Okay, now let's run the game. Let's go to the console. So here I'm going to press P, and of course it's going to print your petting the cat likes it, because we're doing this in the update method using the actual action. But here petting the cat is using the player input component. I'm going to release the P key now, and it's going to say done petting the cat. So indeed these events are being invoked every time the context of the action changes. So when the action is started, when it's performed, and then when it's cancelled. So the philosophy behind the player input component is to actually make the abstractions of the input system a bit easier to use. You don't have to look for each individual action. In your script, you can simply define such methods, one method for each action. And then here you'll notice that we have no reference to the player input script. We just have to define a public method, and in the input test object, our method will be invoked by the player input component. So our code has basically no visibility over the player input script. So you have three workflows that you can use in different stages of your project. If you're just starting out, or if you want to quickly prototype some ideas, perhaps you need to use the player input component with a combination of directly accessing the keys on the keyboard. Then with time, I think that the best way to use the input system is to actually define these input actions, then get them from the project-wide action map like we did here. This gives you more control over the actions, but it's up to you to decide how you're going to use the system. And if you're coming from the old input system, now you have a way to use the new input system without changing your habits too much. But I urge you to look into the player-centric approach, because in the long run, it's quite interesting to use and keeps your code rather easy to write and independent from the actual device that you use. So later on, if you decide to support gamepads or joysticks or touch screens, then you can do it seamlessly without changing your code at all, or maybe just a tiny bit. All right, that's it for this tutorial. Thank you for watching. Check out my channel for awesome tutorials and courses, and click the link in the description to access my course, which is on Udemy, where I show you how to create a complete game from start to finish. Thank you for watching. See you in the next one. Bye-bye.